I'm a bit worried that no one knows where their nitrogen goes. Nigel, you should know. Letting straight up. No. Anyway, I'm not from the north. I have worked in the south, so but I'm incorporating a lot of information that's from around the country. If anyone saw what Peter Heyman said before, and old people like me and Nigel would have seen this slide. Everything I'm going to say now is gone. How many farmers have seen this or growers have seen this after they've applied fertiliser? Come on. If you've done it, if you've seen that after, your fertiliser is totally gone. It's gone. Denitrification, it's totally out of the picture. So what I'm saying here is when you've got a reasonable season and or you've got a system like that, these slides, probably David Roger or someone may have shown, that's just across the fence. That guy managed it a whole lot better than that guy. Okay, so you don't want that. The bottom line, the summary after everything I say is get your organic matter levels up, get these places drained, keep the water from ponding and saturating, and you've got half the question, the answer straight away. So what I'm going to talk about here is maximising how much gets into the grain and maximising how much is left in the soil. You can get it into the grain, but you haven't lost it all if through management you can still leave some that you can pick up later in your rotation. Quickly, just to go through some of the aspects here, you put fertiliser on, it's not just going to magically do things. There are bugs there, microbes, that do the work and transform it. Ammonia is put on, all come from organic matter. Nitrified ammonia is produced in alkaline situations and nitrous oxide. Nitrous oxide is a small amount of gas, a trace gas, but it's a fantastic indicator if you've got problems with your system. And I'll talk more about that later. Produces nitrate, and then I'll just talk briefly about ammonia first, particularly with the alkaline soils that are probably more so in this region. Volatilisation, you've got to get it into the ground. Ammonia, lime, mixes. So the problem with volatilisation, it is manageable. So I'm not going to get into it much here today at all, but it is something you can manage. The big one though is this loss, which I just showed before, denitrification. N2O and N2. N2O I can measure. You can measure it. You can send me a vial, I can measure it and tell you how much N2O. N2 is in the atmosphere now. 78% of our atmosphere is N2. So if you send me a vial, well, it's going to be pretty hard for me to tell you how much N2's come off. It can be done. Now, leaching, okay, that's in some situations maybe more so across into the Mallee and that, and maybe other places on the Eyre Peninsula. What happens? Water relations are key to this. So this is the production of a nitrogen gas, N2 and N2O. And water-filled pore space is how much water is in the pores of your soil. So it's increasing in water content across here. This is where you're saturated. This is about drained upper limit here, or field capacity. This is about your lower limit. So nitrification operates here. You get a bit of N2O because there's oxygen still. It's not all water, there's oxygen. So you get this bleed of N2O. But once all the oxygen's gone, the system's saturated, you get this big belt of N2. And that is what that waterlogged or saturated system I showed you actually spewed out N2. Now, I'll just go back quickly. N2O, it is a greenhouse gas. I'm not talking about greenhouse gases here today, but Peter Heyman mentioned it as well. It is a very good indicator of other losses in your system. Only 1% of your fertiliser may be lost as N2O, but it could be indicative of another 50 kilos, up to 50 kilos of N2 being lost if you've got a saturated system at the wrong time. If you've got a big chunk of fertiliser sitting there, the crop hasn't picked it up, and you get a rainfall event 2, 3, 4, 5 inches, you might get a saturated system that you could lose it. So, just to give you an idea, this is just some data. This 80% water-filled pore space. The system is not saturated. It's above field capacity, but it's not saturated. So, over 7 days, and you will get in the subsoils saturation and the gas will diffuse. There's this thing here called the N2, the N2O ratio. What happens is, over time, more N2 is coming out. That's at 80%. At 100% total saturation, look at this. If I go out and measure 1 kilogram on your soil being emitted after a week, you're probably losing another 50 kilos. So all I'm trying to say here is there's this movement from below that people don't actually realise, that if your nitrate is moving down, water's moving down with it. If you get a saturated system, it'll all come back up again into the air. You won't see it ever again. Now this is just this is at the top end. This is over in Hamilton though. This is coming out of a pasture, and this is what I don't want you to do, or try and avoid this. This is a saturated system whereby they did get a lot of rain in 2010. These big spikes are nitrous oxide. Normally in 1 year you would get 1 kilo of nitrous oxide. In 1 day these guys are spitting out 1 kilo. See this red? This is the soil water here. It's saturated. So 35 kilos of N2O went out to the atmosphere. You know what I mentioned before, N2, N2O ratio, how it can get very big? Multiply that by potentially 50. This has come out of a pasture. So I'm just saying, coming out of some of these rotations, pastures are great, drainage, but these are the sort of numbers that unfortunately we're seeing if things aren't managed properly. This will happen for about a year, but then it'll come back down again. Just to look again more carefully, this is in the surface soil, how it's saturated, 80%, but below it, this is the blue, this is that same period of time, that's the topsoil here, there's 1 and 2, 3, 4 and 5 are the layers below. See, 100% saturation for 10, 20, 30 days. So they're just the constraints you have. Soils, it's not all just happening in the surface. It moves down and it'll stay wetter longer. So the more you can get that water through that system, improve your aggregation, get organic matter in there, the better it'll be. What are we after? Optimally, you want to get yield here and you want your N losses minimal. You want your N losses 0 if you can. But in many cases, people will apply too much will be sitting there at the wrong time, your yields will plateau out because your N losses are coming up. So you really want to be here on this yield and N loss sort of optimum. It can be done, adding fertiliser when you need it. Okay, I honestly cannot sit up here and say the best time to put the fertiliser on is now or middle of the season or split. There is no definitive answer. We have such a climatically variable environment, and Peter Hayman's talk before hit that nail on the head. But there is more information out there now than ever before to say there's X amount of rain potentially coming in the next 3 to 4 or 5 days, and longer term and short term forecasts that you can use to make those decisions. But don't put it out there when the crop can't take it up. Do not put it out there, because if you do get an unusual event, you'll lose it all. Enhanced efficiency fertilisers are out there, and that's like inhibitors, nitrification inhibitors, you would have heard them. There's probably lots of snake oil out there too, and things you spray on and all these other things. They all cost money, and there's not one of them that's cost effective at this point in time. Some of them have a lot of promise, but I'll talk a bit more about that in a sec. Reducing nitrogen application rates by taking into account residual soil N. Yes, that's the question everyone asks. How much is getting spat out by my soil organic matter and my residues? This is just an example, and there's some rules of thumb later in the talk. So I've just taken around somewhere around Roseworthy here. This is rainfall, this is the months of the year, and here's temperature. And just a very simple model that we use, and this tells you that from soil organic matter, not from your residues, from soil organic matter, you'll get a small bleed in the top 30 centimetres of about, in this case, about 30 kgs of N. It's bled out during the season. You don't really have to worry about that as a loss. Let's put your residues in there from the past season. Once you get a bit of rain here to push them along. So you've got these residues that are mineralising, but that N can be lost. And you can see here, you might get another 20, 30 kilos of N there. But that is, when the crop's not in, that's when you're going to lose it. That's where careful management or getting that water into the system. These are just some rules of thumb, but they are very general, and they're not soil type specific, they're pretty general. For every for every 0.5% of carbon in the top 10 centimetres, you might get about 13 kilos of N over the season. Nitrogen from there, that nitrogen is not really prone to loss. It's bled out slowly. Residues, there's a couple of other numbers there for grains and for legumes. That is prone to loss, particularly early on when the crop's not there and if you get a significant rainfall event. Placement, okay, rate, timing, products and placement, you've heard it all before, but again, I can't sit here and tell you this is the definitive way. Rate, there's a lot of trials going on all over Australia at the moment. Sorry, I'll go back. There isn't a lot of trials. There are a number of trials going on. There should be more. You can see here, this is around Guangdi, and again, we want to know where this optimum is. Again, applied N, where does it plateau? As soon as you hit that plateau, you can see here there's a rainfall event, bang. These ones where there's too much fertiliser going on, for that system, all the N has been going off into the atmosphere, gone forever. We use a thing called fertiliser, nitrogen 15. We purchase special fertilisers that let us trace where the fertiliser goes. This is just some data, recent data from Wagga. 100 kilos of N put up at first boot. And you can see here 25, 50 and 100, but they were all applied at first boot. And this is a no-till trial and a tillage trial comparison. The plant picked up about 40%, but there was still another 30 to 40% left in the soil. Not a lot of difference. You can see 80% recovery, 70, 60. Again, it depends on the season as well. You've got to be looking ahead where the losses occurred. Timing. This is Wimmera, Roger Armstrong and Co. Again, these, the 50 and this DMPP is the NTEC product. So this is after the end of the season, applying 50 up front, 50 with DMPP, 50 at first boot approximately, 50 with green urea approximately around first boot. And you can see again, in the end, the late application was the way to go. And that also happened for the 2012 season. The data is just a bit flatter. But again, putting it up front in this case was not the optimum way to go. Keep it for later when the crop can pick it up. This is near Hamilton, higher rainfall zone. So sorry, but this is about the only data that's around at the moment. Again, they applied 100 up front. Look how much they recovered, 20%. And 80% here. Again, this was all applied later. So they're just examples. There's examples that there's not one rule that fits all. There's many different rules, and you've got to take all these decision-making points into consideration. Products. You might have heard of a few of these. The NTEC product. There's a product called N-Trench, which is reasonably new, but it's come out of the US, but it's more so for UAN people. If you're putting UAN on, the N-Trench, I think, works better. And polymer-coated urea. Not a lot of information around at the moment, and I'm sorry, this is from Queensland, but it's indicative of the data we're seeing about losses around the country at other sites. So this is N-loss, okay? N2O indicative. don't worry too much about the scale, but that's loss, increasing. This is during the year. The blue are rainfall events, and you'll get these spikes in N loss with the rainfall event. Okay, there's our urea that we've applied. There's N-trench, that's the nitropyrin product. There's the polymer, and there's N-tech. I must admit the N-tech product has probably been the most consistent of anything we've seen, but nothing is totally consistent, and they all cost more money than you will make at present in terms of profit. This is pretty typical of what we see from Mike Bell's trial. That was at the same trial. Really, when you take all the error bars into account, there isn't any change in yield, protein or dry matter. So again, we have different enhanced efficiency fertilisers, but it's early days yet. And what we're seeing is they'll work better in some regions than others. And they're more suitable for some regions than others. Placement, I won't get into that, but I will talk about volatilisation because it is something, because if you're going to come in and top dress and you're going to put it on the surface and you have an alkaline soil, you're going to have problems. This is a pretty busy chart from Graeme Schwenke, but this is a fallow, the first bar here. This is with lime, so this has had free lime at the surface. This is planted within the crop, and this is with a crop in the system, and this is a top dressing, and this is just on a pasture. Over here is the amount of N that was lost, the applied N in terms of percent. And you can see here, the one I want you to look at is if you're ever applying ammonium sulphate, you probably know, you can get big losses, 25% if you just top dress it, if you have an alkaline soil with a high carbonate content. So beware. Using green urea helps, but you can see you can lose 5 to 10, about 5% is pretty consistent in terms of surface applications of all of these products on an alkaline soil. Okay. Rotations, I won't get into those. I know there are other talks here about bag nitrogen versus legume nitrogen, critical in the decision making. I've already mentioned this, but I don't want to push it, only that these are measurable indicators of your inefficiencies. It is difficult to get this quantitative information in the past. We've been using these now to say, hey, if we have a lot of N2O coming off, you'll have a little bit of CO2 and you'll have a lot of methane. You'll only get methane after a few days, but there are some paddocks I've gone on where you can smell methane. I mean, that person should probably stop farming. I mean, they've just totally screwed the whole thing up. But they are indicators of other losses. And it's carbon that is the key to all of this. You need carbon in your systems. In this system, very different. Very little in terms of N loss, N2O. We get very little in terms of measurements. A whole lot of CO2 coming off. Some people might say, wow, too much CO2. It's not. The more CO2 you've got coming off in these systems, it means you're putting carbon into the system and it's pumping it out. It's balancing it. So high CO2 outputs in systems like this where you're putting a lot of carbon in is fantastic. You're on the right track. Methane, you shouldn't get any at all. So the take-home message, as I said at the very start, more soil organic matter. You've heard that for 20, 30 years probably. What does it mean? Less bag N, better soil structure and drainage. You've got to let the water in to make things happen, and better crop health. You could also see there when it's all flooded, the crop's not going to grow. It's totally got no oxygen. It can't do anything. You get reduced gaseous nitrogen losses, reduced periods of saturation. Apply the N when the crop demands it. I know from practical purposes it is very difficult to get in there at certain times. So what I'm providing here is just a range of options. Enhanced efficiency fertilisers can reduce loss but are not cost effective. Some of the costs are just out of the ballpark at the moment. But I think N-tech's coming down in cost. That's what I've heard from Incitec Pivot. It comes off patent soon and it'll be quite a bit cheaper, so maybe that's an option. Peter, I think Peter's next door talking at the moment. The seasonal forecasting and using models is a good way to go because it gives everyone an individual sort of site to look at. Every farm is different. If you want some more information, you'll find it at this site here, n2o.net.au. There'll be more information over time. What it is, it's basically most of the people involved in nitrogen research in Australia are involved in these projects to pull together nitrogen loss information. Still a lot more to do, and get more information from around here. Okay, thanks.